So what can you now do with that workflow? When customers are coming to us, usually and they want to do PCB simulations, we usually have a schematic or a plan in our head that we go through to identify what the problem is and what the simulation flow should be. And we usually start with power integrity, because once we have the power integrity fixed, the signal integrity will be a little bit easier. Voltage fluctuations and DCIR simulations are probably not in the bucket of power integrity, but we put it in here. But the most important things is impedance measurements on your power plane. That's very easy. You just put a port, and then you can basically extract your impedance like any other S parameters. Or you do a planar impedance resonance analysis where you look at the ground bounds and the potential difference between different layers. Target impedance, I think everyone knows what it is, to try to fulfill certain targets. In the end, we use that target impedance, or the tool uses it. If you want to, for example, do a decouple optimization with different or many decoupling capacitors, you can bring them in and run it, and then the tool will find out the best decoupling strategies for your board. That's the DCR setup. I just quickly go over it. Not just good for delivering clean voltage to your consumers, also good to avoid current crowding and hotspots in the power, so that the thermal design is a little bit better on the PCB. Eigenmode analysis, as I said it, the most easiest. That's why we're proposing it in the beginning. Because you don't have to set up any excitations. You just run the board, and the eigenmode solver will find the different potential constellations between different layers. And then, yeah, the goal is to have a unified potential at different frequencies to then reduce not only the ground bounds, which affect signal integrity, but also then get the spikes out that could happen in the EMI test in the chamber later on. Signal integrity, I just wanted to mention two things because I think I'm already over time. But so you could, for example, as a designer, bring your board in and do a couple of scans. So for example, an impedance scan along traces, or you could even do a crosstalk scan. And I really like that plot here, where you put in violations before, and then you can easily see in a matrix design a type of a plot where your violations and where your warnings are and where you are within your thresholds. Because you can then just pick in one, and you can see directly where the crosstalk happens, or the unwanted crosstalk, and then you could move, change your design and move lines away. DDR5 compliance included, so you have a wizard there, which after you defined your IBIS files to terminate your traces, move the entire schematic and the PCB into your transient circuit simulation, and then run different bit patterns to check what your eye analysis says. There's also a JEDEC compliance tool that gives you a little bit more capability in terms of am I compliant within different ranges for DDR4 or DDR5. And then the last thing, the near field and far field analysis, because we have set up the transient simulation, the bits are running over our board, we can set up other sources. So we could basically now look at near fields like a E field or like a H field scanner, or we put that entire board and put it into the final destination where it should be into the platform. In that example, it's a car. One thing I wanted to mention, the installation comes with CISPR 25 examples. So if you have a board and you have to comply to CISPR 25, there's a radiated and conduction emission set up already there. The dimensions are all correct. You can move your board into the right position. Antenna is in place. The circuit design or part of it has the right stabilization network and the right terminations already, and then the excitations with including a jitter. So of course you see all the coupling happens in that HFSS project file that we have embedded into our circuit, and the circuit then drives everything. So that's a little bit our proposal, how to go through PCB analysis and make sure the PCB is pre-compliant before it goes into the chamber and so on.